Hello my dear students, this is Akash HD. Welcome to the ASD physics classes. Hope so you all are doing really great. So students, in this video we are going to learn equations of projectile motion, and we will also learn the basic terms related with the ground to ground projectile motion. Simply I will tell projectile motion like maximum height, time of flight, range, equation of projectile, and some important formula and all that. Okay, so let's start the video. So you can see very well here one projectile motion is there. This is projected with speed u from the point O, that is called the origin. Its horizontal component is u cos theta, vertical component is how much here? U sin theta. U cos theta I will write here ux, and this u sin theta I will write here uy. Okay, and after that, see here, the time taken to move from point O to A is called the time of ascent. At point A, at the highest point, only horizontal component of velocity will be there, and that will be u cos theta. Okay, vertical component of the velocity will be 0, because after that it is not going more upward. And after that, time taken to move from A to B is called the time of descent. And you can see very well at point B, the velocity is what? We can write here, this is the u, this side component u cos theta, this side component u sin theta. See very properly, here speed is u, here also speed is u, but in absence of air, velocity is different, because here direction upward, here direction downward. Is it? Speed same, but velocity different. Is it? So O to A, time of ascent, A to B, time of descent, and overall time, that means O to B is called a time of a flight. Is it? So if I can tell here at point O, this is t equal to 0. So at point B, it will be t equal to capital T. Is it? This is about the time. After that, if we talk about here, how much maximum vertical distance it is traveling, that means from ground to the point A is called a maximum height h. Is it? Third term, I can tell range, horizontal range. That means we are projecting from point O, and after traveling all this, it is reaching at point B. So this capital R is called what? This is called the horizontal range. Is it? So time of ascent, time of descent, overall time of flight, then maximum height, and then this range. All these things is involved. Okay, so now let's see here. You can see, let an object be projected from origin at t, 0 with initial speed u, making angle theta from x-axis at point p x, y. That means here its speed is v at t equal to t. Is it? So at point p, how much time is there? I can tell here at point p, students, the time is the t. Is it here? T equal to t, where? At this point here. Is it? As shown in a diagram. Is it? Now students, let's see here, we are going to write here the 1D motion along x-axis, because see here, this projectile motion is the two-dimensional motion. But to analyze it in a very easy way, what we'll do, this two-dimensional motion we will convert into two one-dimensional motions. Okay, so for that we are writing the equation. See, 1D motion along x-axis, as I have told you, and when I will use the equation of motion, initial and final point is required. Initial point O, final point P. This is point O and this is point P. Here time t equal to 0, here time t equal to t. Is it? Even at point A also, if I just write here what time will be there, you can tell me very well. At point A, time will be t equal to t here, not time of ascent here. Is it? So now let's see here, these equations I am going to see here. Is it? So see here please, between point O and P, we are going to focus along x direction only. So here what is this? Here component is ux. Here component what is there? Vx. So I can write here, see, this Vx equal to ux means u cos theta. What about the acceleration? As there is no air resistance and all, the charge part, this particle is the neutral. So I can tell here there is no acceleration along x direction. Similarly, along y direction it will be minus g. Why? Because I am taking the mathematical convention, upward plus downward minus. And here what will happen, that here this g will act in which direction? This g is acting in a downward direction. That's why we are taking here the minus. Okay, after that what is the value of the ax? As I have told you, 0 into t. Is it? So hence I can write here this equation, Vx equal to u cos theta. What is the here equation? Vx equal to u cos theta. Is it? We have got here the first equation. Now After that, if we talk about the second equation, delta x equal to uxt plus half axt square, here please. Here coordinate, x coordinate is 0, and here what is the x coordinate? We can tell here x, that means along horizontal direction it is traveling how much distance? X distance, is it? So if I write here horizontal final position x, initial position origin means 0 is equal to ux as it is, u cos theta t plus half ax anyhow 0 only because no air resistance, that means I can write here see x equal to u cos theta t. Is it? Very basic equation, remember that here. Is it? No? So you can see very well we have written here the two equations in which direction? Horizontal direction. Is it? Now after that what we'll see here? We will write here the two equations in the vertical direction. Is it? So see here now. Now if we focus on point O and P, as I told you very well, here time is t equal to 0, and at point P what is the time? T equal to t. Is it? So what is the vertical component at point P? Vy here. Is it? So Vy equal to, and vertical velocity u sin theta here. Okay. And whenever we will analyze the vertical component, we will ignore the horizontal component, and when we will analyze the horizontal component, we will ignore the vertical component. This is called even principle of superposition. Okay. And what is the Ay? Ay I have told you very well, minus g into t. So what equation is forming here? Equation is forming Vy equal to u sin theta minus gt. This is our third equation. That's why I am putting here in a box important. Is it? Now after that here, if I talk about here the fourth equation, you can see here y component is 0, no? Means, or we can tell y coordinate is 0, 0 comma 0. And here what is the y coordinate? You can see here the height is y here, na? Like here height was x, na? Here height is y. So I can write here, see, finally here y, initially here y is 0 is equal to, see here, u sin theta t plus half minus g into t square. Is it? So what can I write here? See, y equal to u sin theta t minus half gt square here. Is it? This is also important formula. That means we have got here equations, four equations we have got, two horizontal direction, two vertical direction. All these equations we will use to get all these important terms like I told you. Okay. Now let's see here the important term number 3. Why 3? Because 1, that means change in momentum, and 2, kinetic energy we have covered in a previous video. Okay. Now let's see time of flight. So here please, what is this? It is the time taken by the projectile from the instant it is projected, that means point O, till it reaches a point in the plane of projection, that means at point B here. Is it? And for that we'll use the equation y equal to u sin theta t minus half gt square. So here 2 points are involved here, point O and B. Is it? That means we are projecting from here, from point O. We are projecting from point O, and it is reaching where? At point B. I told you this is t equal to 0, and at point B, t how much here? Capital T. Now if I ask you what is the coordinates of this, the coordinates of the point B, you can write here ground means 0, and this will be r, 0 comma r. That means I can tell very well, after time of flight, the y coordinate again becomes 0. Why? Because starting from the ground, here 0 comma 0, again coming to the ground, that means again y coordinate is 0. Is it? So this basic we will use here. Okay. So what can I write here? See here please. At t equal to capital T, what is happening here? This y is becoming 0 here, na? Like at point B. This same thing I will put here. So I can write here, see, this 0 is equal to u sin theta into capital T minus half g t square. Is it? So I can write here, see, 0 equal to t is common. So u sin theta minus half gt. Is it? So from here, when you will solve it, you will get here the two solutions, t equal to 0, and second one you make u sin theta minus half gt equal to 0. What you will get here? You will get here t equal to 2u sin theta by g. In a component form, I can write here u sin theta means uy by g. Is it? So this is called what? This is called here, the students, time of flight. This is called here the time of flight. Is it? Kindly see here. 2uy by g here. Yt equal to 0. This is point O. This is point B. Our time of flight is this. This is just the initial time here. Is it? Now students, after that, remember that here, this time of flight is coming from the two parts. One time of ascent and one time of descent. Is it? So if I write here, this time of flight means time of ascent plus time of descent. Is it? Like I have told you, time of ascent means from O to A and time of descent means from A to B. Is it? Now, in the absence of air, time of ascent and time of descent both will be half of the time of flight. Is it? That means I can write here, this will be u sin theta by g, or I can write here this time of ascent is equal to time of descent is equal to uy by g here. Is it? So I hope so. This is very clear to you. Put into the box here. Is it? See. But this thing is only applicable in absence of air, and height from the ground also not too much. Okay, great. Now students, after that we'll see here the maximum height. So what is the maximum height here? See, maximum height, see, it is the maximum vertical distance attained by the projectile above the plane of projection here. Is it? Like I have told you, capital H here. So see, the equation is y equal to u sin theta t minus half gt square. Here you remember that here at t equal to ta, this y will become here h. What I am telling, at t equal to ta, y will become here h. Even I can see here, see, I have told you here. At t equal to ta, this y is there na, see, from O to A, the y will keep on increase, and at point A, it will become maximum, that means h. Is it? This one we are going to use it. Is it? So, see now here, I will use here. So, I can write here, see, this h equal to u sin theta into ta minus half g ta square. Is it? Now, after that here, put here, we can write here h equal to u sin theta, ta value u sin theta by g minus half g, this will become here u sin theta by g whole square. You have to just take common and all, and you have to simplify this. It will come here h equal to u sin theta whole square by 2g. Even in component form, I can write here uy square by 2g here. Is it? This is my, which one? Maximum height is there. Is it? See here. Now, uy square by 2g. Is it? Maximum height is there. Even this equations can be solved by the other method also. Now, if I write here the other methods here, please. Other method. Other. See here, please. This I can use here. See, vy square equal to uy square plus 2ay sy. This is also there. Is it? So you know very well, at the highest point, at point B, vertical component is the 0. Uy how much here? You can see directly, see, u sin theta whole square at point O plus 2ay is minus g, and maximum height is h. Is it? So even from here also I can write here h equal to u sin theta whole square by 2g. Is it? But mostly we used to get by the second equation, not by the first equation. But I have just shown you this equation I have applied between point O and the highest point A. Projection point O, highest point A, between O and A, I have applied this equation. Okay, remember that. Great. Now students, after that here, now next one we'll talk about here the horizontal range. See, it is the horizontal distance traveled by the projectile during its time of flight. Horizontal means we'll use this equation, x equal to u cos theta into t. Is it? So see here, please here, you know very well, at t equal to capital T. That means when we are at point B, this x will become what here? This x will become here capital R here. Is it? You can see here. See, when we are here, the time is t equal to capital T, and see the x value. This is the x value. Now this x value will keep on increase, and here this x will become what? Capital R here. Is it? So this thing we have to remember that here. Is it? So see here now here. Hence we can write here x will become R equal to u cos theta into t. Is it? This is also important equation. I will put here into the bracket. After that, I can write here, see, r equal to u cos theta into t. What is t? t we can write here 2u sine theta by g, is it? And after that, just see here please, this r will become here, I can write here u square, and it will become here what is, students? 2 sine theta into cos theta by g, and we'll get the equation u square sine 2 theta by g. Okay, what is the equation? U square sine 2 theta by g. Even I can write here in a component form also. See from here, this is 2, u cos theta is called ux, this u sine theta is called uy by g. Now, because both of them can be used depending upon the question. Range we can write here 2ux uy by g, or we can write here u square sine 2 theta by g. Both is the horizontal range. Now, very important for maximum horizontal range, is it? So remember that here range means u square sine 2 theta by g. Maximum range means this side should be also maximum. That means in this situation, this sine 2 theta value should be 1, or we can write here 1 means what will become here? It will be sine 90 degree, is it? So from here we can write here this 2 theta equal to 90 degree, is it? So from here what can I write here? Theta will come here 90 by 2, that means 45 degree in a radian, pi by 4 radian here, is it? So for this value what will happen that here? For this value what will happen that here? This range will be maximum theta. And what is the maximum range? This r max will become here, see here please, u square by g. Why? Because sine 2 theta will become what? The sine 2 theta will become here 1, is it? See here please. No? Maximum range value, r max u square by g, okay. Now let's see here students, we are going to see this one here, equation of trajectory of projectile. Now this is the sixth important term we know very well. X equal to u cos theta t, second equation, y equal to u sin theta t minus half gt square. Okay, so from here if I write here the value of a t, so it will become here what? X by u cos theta, is it? X by u cos theta. This one I will just put here. Okay, so it will become here what? See, y equal to u sin theta, t value is what? X by u cos theta minus half g x by u cos theta whole square, is it? So hence I can write here this equation of trajectory will be what here? Remember that here u, this u and this u will cancel out. So see here please, x tan theta minus we can write here, see, g by 2 u square cos square theta into x square here, is it? So g by 2 u square cos square theta x square. Okay, this is what here the students say, this is called here the equation of trajectory here, is it? Even we can write in this form also. I can write here, see, y equal to ax minus bx square here, is it? What we can write here, y equal to ax minus bx square also. In this what will happen that here, if I will compare, the value of a will be what? Tan theta. The value of a will be, students, tan theta, and the value of b will be how much here? Just compare the coefficients of x square. So b will be g by 2 u square cos square theta, is it? And one more form is there, to write the this equation of trajectory. One more form is there, remember that here, y equal to x 1 minus x by r here, is it? I will just write here x tan theta 1 minus x by r here, na? Maximum to maximum, this is the correct only, y equal to x tan theta 1 minus x by r. What is the r? R is the range, is it? And kindly see here very well, as y is quadratic function of x, you can see here the y power 1 and here x power is what? 2. Hence the trajectory of projectile is what? Parabolic path. That means which path it is following, we have drawn like this, na, that is called the parabolic path is there, is it? So sometimes this also required, this also required, this also required, depending upon the question. Okay, so now whatever things we have learned like h, r, t and all that, we are going to write in terms of a also and in terms of b also. Let's see what are the formulas are there. Let's take for example r, h, t and u in terms of a and b. See here, we know that equation of projectile is what? Y equal to ax minus bx square. Okay, so see, range we can write here r equal to a by b. Even I have taught you this also, u square sine 2 theta by g in a component form. I have taught you 2ux uy by g. Is it? Similarly, maximum height, we can write a square by 4b. And what I have taught you? I have taught you u sine theta whole square by 2g. In a component form, I can write here uy square by 2g. Is it? After that, see the time of flight. What is this? A root 2 by bg. This I have taught you 2u sine theta by g, or I can write here 2 uy by g. And one more thing, this initial speed formula is square root of g 1 plus a square by 2b. Is it, students? So if in case they are giving equation of trajectory in a form of y equal to ax minus bx square, just do the comparison, get the value of a and b, and then directly you can get all these important terms and all that. Is it? Great. Now students, after that here, next one we are going to see this one, projectile angle by r and h relation. So see here, sometimes they will tell r equal to like r equal to 2h, r equal to 3h, r equal to 4h. So how to get the angle of projection? So see here please, this r means in a component form, I can write here, see 2 ux uy by g is equal to n, and what is h? H means you can write here uy square, that means uy into uy by 2g. Is it? So what other things can be cancelled out here? Both the sides, this g cancel, and we can write here from this 1 uy is also cancelled here. Is it? That means I can write here, see this uy by ux. Is it? Uy by ux will become what here? It will become here, see 4 by n. What is uy? You know very well, u sine theta. What is ux? This is the u cos theta is equal to 4 by n. Anyhow, you cancel. That means what we can get here? Tan theta equal to 4 by n here. Is it? Very, very important. If in case they have given r equal to 4h, then r equal to 4h means n is 4, theta is 45 degree. Na? Intelligent you are. Next one, see projectile angle by RT relation. Here what is given here, see if they are telling r equal to nt square here. Na? So what is r? Kindly say here, r means 2 ux uy by g. Even you can write in angle form also, it will prove no problem here. Into n, what is t? T is 2 uy by g. So t square means it will become here 4 uy square by g square. Correct? 2 uy by g whole square. So this will come. After that we will cancel the things and all. See from this g, 1 g is cancelled, and from 1 uy is also cancelled. Is it? That means I can write here, see this 2 ux is equal to, I can write here, see 4n uy, and the g, 1 g is left now. I have taken g value 10 approximation. Is it? So from here, what can I write here? Students, see this uy by ux, uy by ux. What this will come here? This will go this side here. So 10 into 2, 20 by 4n. What is coming? 20 by 4n. What is uy by ux? You have seen very well also. It will come here tan theta. Is it? So tan theta is equal to, just simplify this. It will come here. Tan theta is the 5n. If in case they told here like r equal to 4h, na? Any number they can give. So here theta equal to tan theta equal to 4 by 4, theta equal to 1, that means theta equal to 45 degree. Is it? Similarly, if they are telling r equal to 5t square also, in this situation also, n value how much here? 5. So 5 by 5, tan theta is 1, that means again theta 45 degree. So whenever theta 45 degree, r equal to 4h and r equal to 5t square is valued. Any value of n they can give. R equal to h, r equal to 2h, r equal to 3h, or r equal to 2t square, 3t square, 5t square, anything. Just use the direct formula, you will get the answer here. Is it? Next one, let's see here students. In this, relation between angle of elevation phi and angle of projection theta. So see here please here. When projectile is projected from point O and it is reaching at point A, is it? So if in case there is the one observer standing at point O and observing the highest point, is it? So this will be called what? This is called here the line of sight here, is it? So let's take this line of sight is making angle phi from the horizontal. This is called what? Angle of elevation. One observer is seeing the highest point. What is phi? Angle of elevation. Is it? Even you can see, if I see from here, see this one here. Now you can see here, even I'll write here, see, I can write here, let's take this is point M. So can you see one triangle? In the triangle you can write here, in triangle OAM. is it? So tan phi means angle of elevation. Tan phi, what we can write here? Opposite by adjacent, that means AM by OM. What is AM? AM is the maximum height, that means H. What is OM? That means R by 2. So we can write here 2H by R, is it? Now students, we can write here, see this tan phi is equal to, kindly see very well, this is 2. H is given by, see here, uy square by 2g, and R we know 2ux uy by g, is it? I am writing in the component form here. So what will happen that you see, this 2 will cancel out, is it? From this g will cancel out, and from this uy, one uy will also cancel out here, is it? So you can write here, students, see 1 by 2, it will come here uy by ux here, is it? So hence we can write here tan phi is equal to 1 by 2, you know, ui by ux means u sin theta by u cos theta, it will become here what? Tan theta, after cancelling u and u here, is it? So this is the relation between what? This is the relation between angle of projection, that means theta, and this angle of elevation phi. Tan phi equal to half tan theta, is it? Next one here, students, some important point is there. Derivation not required, but remember that here. See here, yes. There are two values of time t1 comma t at which projectile is at the same height y. The sum of these two values of time is always equal to the time of flight here. What I am going to tell you, remember that here. See, let's take here, body is projected at t equal to 0. At point P, how much time is there? T equal to t1. At point P, how much time is there? What I am telling you? T equal to t1. And at the same height, let's take, I will draw here like this here, is it? Same height here, is it? Now here, let's take, this is point Q, this is time is t equal to t2. And at point B, what is time is there? T equal to capital T. So except maximum height, you can see here, at any point you can draw the lines, horizontal lines, two values of time will be there. So here t equal to t1, here t equal to t2. So the sum of these values of time is what here? See here please, t1 plus t2 is equal to capital T here, is it? If you will think about the symmetry, you can get very well here, is it? So t1 plus t2, how much here? Capital T, because you know very well, from here to here, t2, even this t1 time can be replaced here. So t2 plus t1, total will get what? Time of flight here. Very, very important. Next one is here, second point. At 2 points of the same height y, that means point, what can I tell here? Point P, and this I told you, point Q. What will happen that here? Magnitude of average velocity in horizontal direction. You know very well here, Ax is always 0. That means there is no change of velocity in a horizontal direction. That means in horizontal direction, velocity, average velocity will be what here? U cos theta here. Now, magnitude of average velocity in vertical direction. Why? Because see here, the vertical component of the velocity Vy is upward here. If I draw here, let's take here, I am drawing here Vy. So here the component will be this side here. Getting? The component in which direction is students say? The component will be this downward direction here. Is it? Here I am writing here. See, Vy here. Is it? And this is the velocity at point Q here. Okay, just let me see here. See, this is the velocity at point Q here. See, this is at point Q. Even I can write here, this is at point P. So here you can see here vertical velocity upward, here vertical velocity what? Downward here. Okay, this also I can draw here, not a problem here. This is the, I can write here Vx. So you can see this is upward, this is downward, both will cancel out. How much magnitude of average velocity in vertical direction? It will be 0. It will be how much here? It will be 0. Okay, and see magnitude of resultant average velocity now between 2 points at the same height. Remember that here. Remember that u cos theta, is it? Can you see this? Is it? So students, I hope so. This video based upon the different terms, equations of motion, of projectile motion and all is very, very clear to you. Very informative video. Keep studying, keep growing.